This is the FAA Part 107 Remote Pilot Study Guide for 2025. After watching this video, you'll have the tools and information necessary to successfully pass the FAA Part 107 exam. You'll be able to use your drone footage for real estate, weddings, photography, commercial content, all legally within the United States. This is Drones Beyond. And in this video, we'll be discussing in detail weather, cloud formations, wind conditions, various stages of thunderstorms, stable air, unstable air, and forecasting weather. Everything you need to know. So let's jump right in. The FAA Part 107 Remote Pilot Study Guide starts now. There are more questions about weather than any other topic on the Part 107 exam. And why is that? Well, that's because weather is a critical factor in aviation safety, especially for drone pilots. The FAA requires that drone pilots are knowledgeable about weather conditions and that they understand how these weather conditions may impact their flight operations. And what you also need to know are the rules and regulations. So here's a question for you that you should already know. What is the minimum distance, both vertically and horizontally, from any cloud formation? And if you need to think about that answer, then you need to go back and look at the tutorial video number 1. And the correct answer is 500 feet below any cloud formation and 2,000 feet horizontally from any cloud formation. And if there's any question on the exam that asks you who's responsible for knowing this information, well, you can raise your hand and say, I am, because yes, you are the remote pilot in command. So what is weather? Believe it or not, this is a test question on the Part 107 exam, but it's phrased differently. And before I give you the exact question and answer, let me explain something to you right now. Our sun will heat the Earth's surface unevenly, and that's because there are terrains, mountains, bodies of water, cloud cover. And as the surface heats, the warm air will rise and create upward currents of air. These are called updrafts. Now, as the warm air rising begins to cool because of low pressure, high altitude, the moisture in the air condenses into water droplets, thus forming clouds. Now, I had to articulate that for you so you'll understand exactly what the test question actually means. So here's the question. What is the primary cause of all changes in the Earth's weather? If you saw this question before I actually explained it to you, you'd never get the answer. And it's still a tough question, as you can see with the multiple choice answers. But it won't be too difficult for you because you already know that this has to do with a variation of solar heating received on the Earth's surface. Now, commit this to your memory. Warm air will rise as cool air will descend, and the heat that rises from the uneven surface of the Earth will create what's called thermals. And for those of you who want to know what thermals are, well, thermals are upward currents of warm air that form as a result of uneven heating from the Earth's surface. These thermals are the primary cause of what's called turbulence. And I know that all of you at one point have flown on an airplane where you have experienced the bumping and the shaking. Well, that is because of turbulence. But don't think it's so bad, because sometimes pilots take advantage of the warm air rising to gain altitude. Gliders, hot air balloons, and even birds. You need to know and understand this information if you are a remote pilot, especially if you're flying a drone. Now, here's a Part 107 exam question for you to answer. What condition would most likely cause turbulence? Would it be A, stable air, B, smooth consistent winds, or C, uneven heating of the Earth's surface? Well, you should already know that answer because I just gave it to you. And can you see how ridiculously wrong the other two answer choices are? Well, expect that on the exam also. Now, what other natural phenomenon do you think would affect the performance of an aircraft or a drone? Well, you just guessed it. Wind is what you're going to be fighting against to maintain altitude and position, not to mention how wind can suck the life out of your battery when flying. And also there's wind shear, something that's sudden, unpredictable, and potentially dangerous. And what actually is wind shear? Well, let me explain. Wind shear is a sudden drastic change in wind speed or direction over a small area. This sudden violent change in wind is dangerous to any aircraft, including a drone. And a wind shear can occur with upward drafts or downward drafts at any time. Now listen, I witnessed an airplane coming in for a landing heating and a sudden downward microburst caused the plane to crash before it even got to the runway. This is why the FAA wants you to know this information. And here's something else you need to know for the exam. Question: at what altitude can wind shear occur? Now I want you to look at the multiple choice questions and choose the correct one. And while you're doing that, don't forget to hit that subscribe button because I've got more tutorials coming for you in the near future. Now going back to the question, if you answered C at any altitude, then you are correct. But I want you to keep this in mind. At lower altitudes closer to the ground, wind shear becomes much more hazardous, and you now understand why. Now flying your drone in windy conditions could become problematic for several reasons as outlined in FAA Part 107 study materials. Here are some of the potential concerns. Number one, you could lose control because strong winds can push a drone off course, making it difficult to maintain stability or perform precise maneuvers. Number two, battery life reduction. The drone's motors must work much harder to counteract the wind, draining the battery much faster than it would in calm weather conditions. Number three, return to home issues. If the drone is flying with the wind and gets too far away, it may be difficult for it to fly back against the wind, potentially leading to a crash or even a flyaway. I don't think you'd be too happy after you paid all of that money for that expensive drone. And number four, sudden altitude changes can occur if you have high winds or wind shear. As a remote pilot in command, it's important for you to understand what factors will contribute to you not having full control of your aircraft. Now let's recap and clarify why it is that winds happen globally. You see, global winds are caused by the uneven heating of the Earth's surface. You already know that. And the uneven heating of the sun's radiation is due to the differences in land and sea elevations, and also the clouds that block the heat from the sun in various areas on the Earth's surface. Warm air rising creates low pressure while cooler air creates high pressure. And as the air moves from high to low, that generates wind. Now here's a Part 107 question for you. What causes global winds to form? Could it be A, the rotation of the Earth's surface and differences in air pressure? Or B, the movement of the ocean's currents affecting atmospheric conditions? Or C, the gravitational pull of the moon on the Earth's atmosphere? Now if you selected A, then you are correct. Now let's talk about clouds and the various types of cloud formations. And a good question to ask is, what are cloud formations and how many types of cloud formations are there? Now, anyone who's taken the Part 107 exam will tell you that you need to know the answers to these questions. So at the end of this section, you're going to understand cloud classifications and how they impact drone operations. So let's start by talking about all of the cloud classifications by altitude. Now, from the surface to 6,500 feet AGL, you'll find low-level clouds. And the first low-level cloud formation we'll discuss is stratus clouds. Now, stratus clouds are a grayish, low-level cloud that appear like a thick, flat layer covering the sky. They form at lower altitudes below 6,500 feet AGL. Sometimes they look like fog that are up higher in altitude. Now, it's very important that you remember what I'm about to say. Stratus clouds generally will bring light rain, drizzle, or mist, and they can also cause reduced visibility. But the key thing to remember here is that stratus clouds are often linked to stable weather systems, but persistent stratus clouds can also be a signal of poor weather. Now, in regard to how this type of cloud formation affects drone operations, well, you'll find that visibility will be reduced just enough to make it difficult to maintain visual line of sight, or VLOS. Also, you may have issues with ceiling restrictions since these clouds are at low altitudes. Pilots and remote pilots should avoid flying in dense stratus layers due to poor visibility and difficulty in navigation. Now, here's a Part 107 question that may be a little tricky. Which one of the following cloud types is most likely to indicate stable air and poor visibility? Now think, what cloud formation did we just discuss and what were the characteristics of that cloud formation? Well, if you selected C, stratus, then you are correct. And later we'll be discussing the differences between stable air and unstable air. Now let's move to the next type of cloud formation at low level, and these types of clouds are called cumulus clouds. And it is very important that you recognize this type of cloud formation because it will be on the Part 107 exam. So start taking notes. Cumulus clouds are puffy, white, well-defined clouds often seen in fair weather. They have a distinctive flat base with a towering dome-shaped top, and they often resemble cauliflower or large cotton balls. But what is so important to remember is that these cloud formations can develop into larger storm systems like cumulonimbus clouds. And I promise you we'll be discussing cumulonimbus clouds in detail in just a few minutes. As I mentioned, cumulus clouds are white, puffy, fluffy clouds, and they will typically form at 1,000 feet to 6,000 feet AGL. But they can grow much taller, especially if they are developing into a cumulonimbus cloud. Now, cumulus clouds themselves are relatively harmless, and they are an indication of fair weather. However, if they grow large enough, they can develop into a cumulonimbus clouds, which means that they will be bringing thunderstorms, heavy rain, and turbulence. And I know that you all remember these terms because I just went over that a few minutes ago in this video. Now, looking into how cumulus clouds affect drone operations, well, specifically, small cumulus clouds generally don't pose any threat to drone flights. Pilots should be cautioned that they can start developing into a vertical growth. Now, in regard to any ceiling restrictions, the base of these clouds are usually high enough to allow for safe drone operations. But if a cumulus cloud is part of a developing storm, then you better believe there's going to be thunderstorms and turbulence to follow. So let's recap and review some key differences between stratus and cumulus clouds. Stratus clouds, thick, gray, uniform with no distinct shape. Cumulus clouds, puffy, white, well-defined, flat base with a rounded top. Altitude, a stratus cloud will be from 6,500 feet AGL and below. Cumulus clouds, 1,000 feet AGL up to 6,000 feet AGL, but can develop into higher altitudes, especially in warm weather. Conditions, stratus clouds will bring light precipitation, mist, and reduced visibility. Cumulus clouds will bring fair weather but may develop into thunderstorms if they begin to start growing vertically. And since we're on the topic of thunderstorms, let's talk about a Part 107 exam question. And this has to do with the 3 stages of a thunderstorm, and you will see this on the exam. Now notice on the left, do you see that what used to be a cumulus cloud is now gaining altitude because of warm air rising? Well, this is the first stage, and the first stage is called the cumulus stage. So let me explain to you exactly what's happening here. You see, warm, moist air is rising rapidly, and this is due to the solar heating of the Earth's surface. And as the rising warm air begins to cool, water vapor condenses inside of the cumulus clouds, and this is what causes it to start building upwards. Now observe closely. There is no precipitation. There is no rain at this point. And that is because all of the moisture remains suspended. It's being held inside of the updraft. Also, pay attention to this. There's no lightning. There's no thunder at this stage. And that is because the conditions needed to have a strong electrical charge do not exist yet. And on a quick note, rarely will you see lightning at the cumulus stage. All of these details explained thoroughly is what you need to pass the Part 107 exam. And if you're getting value from this video, go ahead, hit the subscribe button. The next stage after the cumulus stage undoubtedly is the most dangerous stage. Stage number 2 is the mature stage of a thunderstorm. And it begins when the storm reaches its full development, producing heavy rains, strong winds, lightning, and sometimes hail or tornadoes. Let's go over the details on this stage. The key characteristics of the mature stage will be the updrafts and downdrafts. Now notice, you still have warm air rising, continuing to not only build, but to fuel the storm. And now you can see the presence of downdrafts, which is descending cooler air. And this cool air that's falling down is also bringing something else with it. The precipitation and the moisture that was being suspended and held there for so long. And to make this condition even worse, the interaction between the updrafts and downdrafts, the warm air and the cool air, is what makes this stage so violent, turbulent, and unpredictable. The storm at this stage is fully developed with heavy rain, lightning, thunder, and intense downdrafts called microbursts. And now do you see why I'm going into detail with you? That's because I want you to fully understand. It is not enough to simply know the answer. This needs to be explained. The mature stage of a thunderstorm will have water droplets that will grow large and fall as heavy rain. And sometimes you'll see hailstones, and that's because the warm air that's rising has enough force to keep pushing the ice particles that are falling upwards, allowing them to grow bigger. Now pay attention to the diagram and look at the downward drafts in regard to their direction. Do you notice that the blue arrows are spreading out towards the ground? And you probably wouldn't even have noticed if I didn't mention that. As the air cools, the downdrafts will accelerate and spreading them outwards towards the ground, and this is what causes the strong winds and wind gusts. And for me to put the cherry on top of the whipped cream, lightning and thunder will begin to intensify due to collisions between the ice, hail, and the supercooled water inside of the cloud. Negative charges will collect at the base of the cloud, while positive charges will build up at the top of the cloud. When this happens, lightning occurs, and the thunder is simply just a shock wave caused by the rapid expansion of air that is heated by lightning. Now that you understand the mature stage so well, let's go into the final stage, which is the dissipating stage. And the key question here is, why is it dissipating? Well, let me explain. At this point, the storm is losing its energy source. And where was the energy coming from? Well, do you remember warm air rising that was fueling the cumulus cloud before it actually developed into the mature stage? Well, you remember those cool downdrafts that were spreading out all over the ground? Well, what was the result eventually? Now you got it. The warm upward drafts eventually were weakened and disappeared. That was the source that was fueling the storm. And now that the warm, moist air has been cut off and the cloud begins to lose its moisture, the precipitation and rain will stop, the clouds will begin to evaporate, the winds will begin to calm down, and there will be a cooling effect on the atmosphere. Now, I so eloquently explained the 3 stages of thunderstorms to you, there's no way that you'll be able to get anything other than a 100 score on this question. So here are some Part 107 questions that I know you'll be able to answer correctly. First question, what are the 3 stages of thunderstorms in correct order? You can pause the video here to write down your answer, and then we'll move to the next question. Have you ever wondered why it is that your drone performs differently on a hot day compared to a cool morning? Well, there is something on the Part 107 exam that has to do with the question I just asked you. And that something is called density altitude. And if you're preparing for the FAA Part 107 exam, well, this is something that you must know about. And I'm going to break it down so that way it's easy for you to understand. Now, density altitude and air density are completely different concepts, but they are related. So let's talk about air density first. Air density is simply how much air can be packed into one given space. Higher density means more air molecules, and lower density means fewer air molecules. And what I'm actually explaining to you is that in different parts of the atmosphere, the air density is different. This is very important because air density affects a drone's lift, the efficiency of the propellers, and battery performance. So let me ask you a hypothetical question. If you were in a sealed room with a drone and had all of the air sucked out, would you be able to make the drone fly? And I can tell a lot of you just started scratching your heads. Well, I'm not going to tell you what the answer is until I am finished explaining air density. There are 3 major factors that change air density: temperature, altitude, and humidity. With temperature, warm air is less dense, and that means that your drone will need to work harder. With altitude, that means that the air is thinner, so it reduces propeller efficiency. Humidity, or moist air, is less dense because water vapors replace heavier oxygen and nitrogen molecules. So if you're flying a drone in hot, humid, high altitude conditions, well, you can expect your drone to have reduced or limited performance. The best weather condition when you're flying your drone will be cool, dry air at low altitude. So going back to the question with you being in a sealed room, a drone would not be able to fly because a sealed room with no air is considered a vacuum. Drones rely on air density for lift, and their propellers work by pushing the air downwards, creating an equal and opposite force. This is Newton's third law. Now, specifically, what you will see on the Part 107 exam is what's called density altitude. And the concept of density altitude is that the altitude is which the air feels like a certain density level. It's based on a pressure altitude adjusted for temperature and humidity. And even if you were at sea level, high temperature and humidity can make the air behave as if it's at higher altitude. And very important to remember for the Part 107 exam, density altitude is not a target altitude. It's simply a way of describing how the air feels. So this is what you're going to have to pay attention to for the Part 107 exam. If the density altitude is low, then the air is thick and your drone will fly efficiently. Now, did you hear what I just said? And were you paying attention and understand that what I just said to you is the exact opposite of air density? And to continue this, if the density altitude is high, then the air is thin and the drone struggles to generate lift. And I just opened up a can of worms because that's the complete opposite of air density. For the Part 107 exam, what you need to know is that your drone will perform better at low density altitude conditions such as cool air, dry air, low altitude. So I needed to break this down so you have a clear understanding of the difference between air density and density altitude. Again, density altitude is simply a way of measuring how much air will affect your drone's performance. Lower is better. Now here's the Part 107 exam question. How does the increase in density altitude affect a drone's performance? Is it A, it improves lift and reduces power consumption? B, it has no effect on drone operations? Or C, it reduces lift, decreases propeller efficiency, increases battery consumption? Well, if you selected C, then you are correct. And I hope these detailed explanations are helpful for you to understand and not just know the answer. Now, let's talk about stable air and unstable air. Stable air is like what you feel when you're standing over a peaceful lake. It's calm, it's smooth, and it's predictable. It happens when the atmosphere resists any vertical movement, keeping weather steady and mild. Now, what you will notice is that your drone will have a very smooth flight. And the next thing I'm going to tell you will be on the Part 107 exam. You will also notice reduced visibility due to haze or fog. Now, do you remember that when I mentioned status clouds that it usually was accompanied by mist and poor visibility, but that the weather conditions were stable? Is this now beginning to make sense that reduced visibility means stable conditions? Now, on the flip side, let's talk about unstable air. Pay attention, look closely. Do you see that the grass is moving from side to side, making you feel uneasy? And despite the fact that those clouds are overhead, that you can see the horizon clearly, what are these conditions telling you? Unlike the peaceful lake, unstable air is like a boiling pot of hot water. It has air currents that can rise and fall. Do you remember that we talked about that? There's turbulence and unpredictable conditions, all signs of unstable air. Now here is the craziest thing. What you will notice is that your drone will have a bumpy, turbulent flight. You'll see cumulus clouds, thunderstorms, strong winds. But what is so contradictory is that you will have good visibility. It's absolutely fascinating that unstable air will allow you to see better. What I'm giving you now is the answer to a Part 107 question. Which of the following are characteristics of unstable air? Is it A, smooth air, poor visibility, and stable precipitation? B, turbulence, good visibility, and showery precipitation? C, calm winds, clear skies, and layered formations? Now, if you get this one wrong on the Part 107 exam, you're going to have to buy me lunch. But it might be better if you just hit that like and subscribe button. Now, I want you to remember this on the Part 107 exam. It will ask you what are the conditions of stable air and unstable air. And you should remember that stable air came with poor visibility and unstable air had good visibility. If you just remember that, that will give you a clue on how to answer the questions appropriately. Now, here's an excellent question that just came to mind. What does this mean for drone pilots, and which air is better for drone flying? Well, right now, let's use our common sense as a reference. Stable air is safer for smooth flights, but you need to watch for fog, and also you must have 3 statute miles of visibility before takeoff. Unstable air, we can expect turbulence and strong winds or even thunderstorms, but here's the thing. The FAA Part 107 rules and regulations do not explicitly state that you cannot fly a drone when thunderstorms are present. However, Common sense will tell you that based on visibility, cloud clearance, and safety rules, that flying a drone near a thunderstorm would most likely violate some FAA regulation, making it unsafe and potentially illegal. So do yourself a favor, check the weather reports, check the FAA advisory circulars, and make sure that you have the correct conditions to fly safely. Now let's move to two other topics in regard to weather that are very important for the Part 107 exam, and that is fog and dew point. I'm going to explain both of these in detail and tell you exactly why this is so important for drone pilots. Let's talk about dew point first. What exactly is dew point? Well, dew point is the temperature at which air becomes fully saturated with moisture. When air cools down to its dew point, water vapors turn into tiny droplets forming fog, dew, or even clouds. Do you remember? We spoke about this in the beginning of the video. Warm air, moisture, and the cooling of this air, convection. This is what we're talking about when we speak of weather. Haven't you ever noticed that in the morning outside that the grass is moist or full of dew, wet? Yes, you have noticed it, but you just never knew what caused it. So here's the science behind it. Remember we talked about solar heating in the beginning of the video? Well, at night, the ground loses heat. And during this time, as the ground cools, it lowers the temperature of the air directly above it. And this creates a certain amount of water vapor. And when the temperature drops to the point where it can no longer hold any more moisture, this is when dew point is established, and it forms tiny water droplets on the grass, the leaves, the cars, and all other surfaces. That is the dew point. Now, did I just break that down like a poet? You understand, don't you? But I'm going to put the cherry on top so you understand even better. Dew point forms best on clear, calm nights. Do you want to know why? That's because there are no clouds in the sky to trap the heat. This allows the temperature on the ground to drop faster. Windy, cloudy conditions prevent dew from forming because the air mixes, preventing the surface from cooling enough. Now, to elaborate on this, there is a difference between dew and frost. Dew is when the water condenses into a liquid. Frost is when the water turns into ice. And if I subtly mention fog before I actually get into the details, well, fog is when the tiny water droplets remain suspended in the air above the surface. Now, there is a more advanced explanation of dew point that I need to go into for those of you who already know about dew point. You see, pilots understand that in order to determine dew point, you need to calculate two things: air temperature and relative humidity. And dew point is actually a formula, a calculation of what the temperature needs to be in order for the air to contain maximum moisture. So as the air temperature drops closer and closer to the calculated dew point temperature, for example, if the air temperature is 27 degrees Celsius and the dew point temperature is 17 degrees Celsius, then that means that the air has not reached dew point temperature yet, so it can still hold moisture. That means that there will be no dew, no frost, no fog. So by me saying this to you, what do you think is going to happen when the air temperature reaches the calculated dew point temperature? And yes, you are correct. Above ground fog will develop with these conditions. But later on in the video series, I'll be discussing the effects of dew point on low-level clouds and atmospherically also. So we've touched briefly on fog. Now let's get into the details. What is fog? Now don't laugh because we're going back to the beginning of the video. Fog is a cloud, but this cloud forms at ground level. You see, when the air becomes fully saturated with moisture, it causes water vapor to condense into tiny water droplets that remain suspended in the air. This is fog. It's like a cloud that forms at ground level, and fog will significantly reduce visibility, which can be dangerous for drone pilots. And if you remember on my first video, the FAA Part 107 requires that you must have at least 3 statute miles of visibility before drone flights. When you're ready to fly, fog should be an indication to you that you're not ready to fly. Fog can drop visibility down to near zero, making flight impossible. Not to mention that flying through the moisture of fog can make the tiny water droplets collect in your motors and your sensors and cause electrical damage. Use your common sense. Also, let's go deeper. How about high humidity and fog can affect your radio signals or your GPS accuracy? These are all things that you must consider when you're a certified remote pilot or if you're simply just flying a drone. There is something called a Meteorological Aerodrome Report, or METAR. This report will give you information on the dew point and all of the weather conditions. We are going to be discussing METAR on 4 of 12 tutorials. You better stay tuned because that is a very important video. It's another important category for taking the Part 107 exam. I think I've talked enough on this video about weather. I'm going to have on the next video METAR reports, TAF reports, so you'll be able to have a complete detailed breakdown on how to read those reports accurately. Don't forget to hit like and subscribe to get the notifications on the next video, which will be 4 of 12. Thanks again for watching, and I'll see you on the next one.